Alright, today we're gonna do complex numbers and quadratic formula. Okay, just to get you ready for the next breakout topic, which is the fundamental theorem of algebra. But okay, just remember, when we get the square root, okay, if I'm gonna do the first problem on your notes, it says write the complex number in standard form. Because if I put in the calculator square root of negative 16, it will give me this, okay, note that says error non-real calculation, because there is no real answer, okay, for square root of negative 16. It will be an imaginary answer. So that's why we have what we call the complex numbers. And complex numbers are the ones that will enable us to do square root of negative 16. But, okay, always make sure that your answers are in standard form. The standard form of complex number is a plus bi. The a is your real number, and your bi is your imaginary. So a complex number can be, okay, a real number and an imaginary combined. Okay, and remember, okay, what will make us be able to do square root of negative 16 is when we change the negative sign into an I. So every time you see a negative sign under the square root of sign, you're going to replace it by the I. And every time you see an I squared, it will be equal to negative 1. Because if you have I is equal to square root of negative 1, if you want to remove the square root, remember we square both sides, so we can remove the square root sign. And once you remove the square root sign, then you have I squared is equal to negative 1. That's why, okay, whenever we see I squared, we have to put it as negative 1. So for the first one, okay, if you're asked to evaluate square root of negative 16, you cannot do anything until we get it to positive square root of 16. So the way to do that is to just change the negative into an I, so that it will become square root of 16 and the I in the back. And then now you can do square root of 16. Square root of 16 is 4, so that's why your answer is going to be 4i. Remember, you have to make it positive square root of a number. Okay, square root of a positive number. Number 2, there's no square root sign with our i's. And we know that every I squared is equal to negative 1. So first thing that we need to do is to multiply first the negative 3 to the negative 2. And that's the real number in our words. So positive 6. Okay, then when we multiply, what do we do to the exponent? We add them up, right? So 4 plus 6 is 10. So it will be 6i to the 10th power. But for every I squared, we put negative 1 on it. So to find out how many I squared are there in I to the 10th, you can just, okay, break it down. And that's I to the 6, I to the 8, and I to the 10. So there are 1, 2, 3, 4, 5 I squared in I to the 10th power. So every I squared is negative 1. So if we replace it by all the I squared by negative 1, there will be 6 times negative 1 times negative 1 times negative 1 times negative 1 times negative 1. So there will be 5 negative 1s. So what will make that, the 6? Positive or negative? Negative. So depending on if you have odd numbers of I squared, it will make it negative. If you have an even I squared, that means it's going to be positive. So all it does is to just make your number positive or negative, all the I squared. Okay? So the final answer here then is negative 6. All right, let's go to, then after we learned about the concept of the imaginary, the i's, we did the operations. When you do operations with the I, you treat I as an x, as a variable. Okay, so when you're adding and subtracting, we combine like terms, in other words. So the 3 and the 2, we're going to add, because the operation is plus. So this will be 3 plus 2, that will give you 5. And then we combine the ones with the i's, like when we combine like terms. So the negative I plus, since it's adding that we're doing, to the 3i. And negative 1i plus 3i, that will give us positive 2i. So when you write your answer, make sure that you always write it in standard form, the real number first in front of the I. Okay, so the 5 goes first, and then since 2i is positive, we're going to put a plus sign. If it's negative, then we're going to put minus. So your answer for number 3 then is 5 plus 2i. Okay, number 4, I combine adding and subtracting. Okay, so the first 2 we're going to add, and whatever the answer, we're going to subtract 7 plus I on it. So I'm going to do the real numbers first, which are the 3, and we're supposed to add 4 to it, and then subtract 7. And what's that? 0, right? 0. Then we do all the i's. So first 2i, we're supposed to add negative I to it, and whatever the answer, we subtract I from it, so minus I. So 2i plus negative 1i is 1i. 1i minus I? 0. So this is 0i. So you can write your answer in standard form, 0 plus 0i, but since it's 0, you can just put 0 also. So either way. Okay? So that's how we add or subtract with imaginary numbers. So same concept. Okay? Remember what I said. The I is just like the X. So whenever you're multiplying also, you're going to do the exact same thing that we did, okay, when it's an X. But before we do number 5, we cannot do anything until the number inside the square root sign is positive. So how can we make it positive? We use the what? To make it positive, we use the I. Okay? So every time you see a negative inside the square root sign, you make it positive by just putting an I on it. So square root of negative 4 then will become square root of 4 I. Remember the I is outside the square root sign. And then times, then we make square root of negative 16 positive again. So that will be positive 16 and then the I outside. Okay? What's square root of 4 times square root of 16? What's 4 times 16? 60. 4 times 16 is square root of 64. Then I times I is I squared. What is square root of 64?
8.
What is I squared?
-1.
Negative 1. So remember what the I squared, what it does is just change the sign. So that means it will change to negative 8. So that means this is negative 8. Okay? So don't multiply, do not multiply negative 4 times negative 16. Because obviously that's going to be wrong. Okay? Make it I first and then multiply. You cannot just multiply them. Alright, number 6. How are we going to do number 6? What's the shortcut? Just cancel out. Remember, if you see a square root and a square, they just cancel each other out. So we can just cancel it right away so that your answer is negative 8. Or if you want to do the long way, because we already know that we can't do anything to it until we get it to positive. So if you change it to positive 8, square root of 8i, square root of 8i, and then square it, it will give you square root of 8 times 8i times square root of 8i, which is square root of 64. Then I times I is I squared. And square root of 64 is 8. Then the I squared just changes the sign. So that's why it's also negative 8. But why do all of that when you can just cancel? Okay, remember square root and square will just cancel. Alright, number 7. It's multiplying 4i to negative 1 plus 5i. And all you do is just treat it like the letter X, so you just do distributive property. So 4i to the negative I, that negative 1, so that will give you negative 4i. 4i times 5i is positive 20. I times I is I squared. Just multiply by distributive property. Then we need to simplify. Okay, the one that we need to simplify is the I squared. Every single time you have an I squared, you have to have a negative 1 in it. You cannot have I squared in your final answer. So this will be negative 4i, okay, plus 20, and then change it to negative 1. So the 20 then will become negative 20. So when you write it down in standard form, you're going to have to write the negative 20 first. So, and the final answer, it's negative 20 minus 4i. Just switch it over because they want it to be always in standard form. The one with the I is always at the back. Alright, and look at number 8, last multiplication. What's that? How do we multiply things like that? FOIL. We're going to do FOIL method. So let's multiply square root of 2 first. Square root of 2 times square root of 2 is square root of 4. Okay, then multiply square root of 2 to negative square root of 8i, which will become negative square root of 8 times 2, 16, and then the I. Then we go on to the next one. So square root of 8i times square root of 2 is positive square root of 16i. And square root of 8, positive times a negative is a negative. Then square root of 8 times 8 is 64. Then I times I squared. And then we're supposed to combine like terms. But what happens when we combine the ones with the i's? They cancel out. So the only thing that we need to do really are, okay, this and this. Okay, what's square root of 4? 2. What's square root of 64? 8. What's I squared? Negative 1. Oh, so what happens to negative 8? It becomes positive. So this will become 2 plus 8, which is simply 10. So the final answer for number 10, for number 8 is 10. Okay, I forgot to put this in pieces. Alright, now look. Oh, is there something familiar with the problem for number 8? They're the same, right? Exactly the same, but one is a plus, one is a minus. If we like factor something like that, they're called difference of two squares. Okay, right? So there's something really, familiar with it because they are what we call complex conjugates. They are a pair of complex numbers in the form a plus bi and a minus bi. So they are, the only difference between the two, one is a plus and the other one's a minus. And it is the sign in front of the imaginary. Okay, remember, the one in front of the I is the sign that will be opposites, in other words. So, if you have, let's say for example, if you have 2i, what's the complex conjugate of 2i? Negative 2i. If you're given negative 5i, what's the complex conjugate?
5i squared.
5i only. Okay, in other words, complex conjugate is just the same number except they're opposite signs. That's what you call complex conjugate. So if you have I, what's the complex conjugate of I?
Negative I.
Negative I. If you have 2 plus 2i,
Negative minus 2i.
okay, that's the one, okay? If you have a real number, the real number will not change signs. It's the one in front of the I that will just keep on switching from opposite. So the complex conjugate of 2 plus 2i will still be 2. That doesn't change. But the one with the I is the one that will change. So it's 2 minus 2i. So the only sign that will change is the one in front of the I. Okay? So let's... Okay. In number 9 and number 10, we're asked to write the complex conjugate, and they give us the complex number. Then we're going to multiply the complex number by its complex conjugate. Because when you multiply, like number 8 is complex conjugate. Okay, when you multiply, you only do a squared plus b squared. In other words, there's a formula to find it without doing all the FOILing, in other words. And that's why we got a number only, because the only thing that we need to do here is to just square the square root of 2 and square the positive 8. And that will give you 10 already. So if you do it here, your a is square root of 2. So it's square root of 2 squared. And it's always plus between them. And then your b is square root of 8. And all you need to do is to just square it again. Square a, square the b, and then add them up. And that will be the answer already. Okay, so what's this? Square root of 2 squared is? They cancel, so that means it's just going to be 2. And plus square root of 8 squared? cancel again, so it's gonna be 2 plus 8. Isn't that what we got? 10? Yeah, because that's the shortcut. For as long as you're multiplying complex conjugates, you just do a squared plus b squared. And that's why 9 and 10